If you believe the best crops always win on merit in America, hold that thought, because this story is going to challenge it. A legume that fertilizes its own soil and tolerates drought is cultivated on almost 4 million hectares worldwide. Yet across the mainland United States, most people have never seen it in a field, a farm co-op, or a grocery aisle. The crop is pigeon pea, Cajanus cajane, a woody plant whose roots form nodules with bacteria that fix nitrogen from the air, so it can add fertility instead of demanding synthetic nitrogen. Studies report biological nitrogen fixation in the range of roughly 69 to 100 kilograms of nitrogen per hectare. Researchers also describe drought resistance that helps it produce in hot, semi-arid climates. In 2012, the United States Department of Agriculture published a plant guide. It lists pigeon pea as a pulse crop for dry seed or as a green vegetable. It also notes that cooking reduces natural trypsin inhibitors. So here is the uncomfortable question. If this plant can feed people and help rebuild soil, why did it never become normal in the country that industrialized farming? Before we go any further, comment the number 9 if you think a crop this practical should be common here. And if you do not agree, hit like to show you do not buy it. Here is the structure that decides what you see on American farmland. And it is not just biology. Agriculture runs on incentives that reward the most repeatable system. And the default system in the United States has been soybeans for a very long time. During World War II, harvested soybean acreage rose to about 10 million acres. Then it climbed to about 30 million by 1964 and about 40 million by the late 1960s. That scale created enforcement, without anybody needing to say the word. Once a crop is that big, everything around it hardens into place. Research budgets, extension advice, elevators, processing, contracts, and the habit of planting the same thing again, because it is the lowest friction choice. By the 1950s through the 1970s, the United States dominated global soybean production. Multiple sources describe it as growing more than 3/4 of the world's soybean crop in that era. Then the system got even more repeatable. In the mid-1990s, regulators approved herbicide-tolerant soybeans for sale, and Roundup-ready soybeans launched for the 1996 planting season. Weed control became simpler, more standardized, more scalable. Now put pigeon pea next to that machine. The USDA can publish a plant guide, and it did. But a plant guide does not erase market friction. No local buyer means no price. No processing means no demand. No demand means no one teaches it. That is how something can be real, useful, and still stay invisible in plain sight. Picture a shrub about shoulder high when it is grown like an annual, with narrow leaves, yellow flowers, and pods that dry down into hard seed. It looks more like a hedgerow than a row crop. That is pigeon pea, Cajanus cajane. And the first thing to get straight is this. It is not a wellness trend. It is a working farm tool with measurable outputs. The USDA Plant Guide says the split seed commonly runs roughly 21 to 28% protein. It also puts crude protein in the forage in the range of about 28 to 36%. That is why farmers in the tropics have used it as both food and feed. The same USDA guide says the plant is drought-resistant because of its deep root system. It reports it has been found growing through a 6-month dry season. It also notes the plant can be managed as a perennial. Under good management, it can live up to 5 years. Now look at the soil side. Because this is where the math gets uncomfortable. The USDA guide describes pigeon pea as a green manure that can fix about 62 pounds of nitrogen per acre, up to the time pods are produced, meaning fertility pulled out of the air and put into the field through biological nitrogen fixation. Not bought in a bag, not spread by a machine. It even gives yield ranges. Mature seed pod yields can run from about 1/4 to 1 ton per acre. Short duration varieties have been reported at more than 2 tons per acre in some settings. Then zoom out to scale, because this is not rare on the world stage. ICRASAT, citing Phaeostat, reports that India alone produced about 4.32 million tons of pigeon pea on about 5.2 million hectares in 2021. Productivity around 825 kilograms per hectare. So when somebody tells you pigeon pea is obscure, what they really mean is it is obscure here. If those numbers sound like a crop that should have a place in American rotations, comment the number 9 again. And if you think this is not convincing, hit like to show you do not agree. Long before soy became a national default, pigeon pea already had a real job in real kitchens and real fields. Archaeobotanical research places pigeon pea as a crop with deep roots in South Asia. The evidence points to a long history of use and domestication in ancient India, not a modern invention. In plain terms, this is one of those plants that shows up again and again in older farming systems, because it does more than one thing at once. It gives people a dependable pulse for food, it gives animals forage, and it gives the soil a nitrogen boost through a partnership with rhizobia in root nodules. That last part matters, because older agriculture had a built-in structure. If a crop could feed you, and also reset the field for the next crop, it got repeated. That is why pigeon pea is so often described as an intercropping companion with cereals in rain-fed farming, especially in the semi-arid tropics, where drought risk is not a theory. It is a yearly constraint. And it did not stay local. Sources describe it as widely cultivated across tropical and subtropical regions, a familiar staple in South Asia, with spread into parts of Africa and later into the Americas through historic movement and trade. When a plant survives that long, across that many climates, it usually means one thing. It is not fragile. It is not a gimmick. It is a tool that fit the old world's default incentives. Feed the household, keep the soil alive, and do it again next season, without depending on anything you could not produce yourself. After the war, American farming was redesigned around one idea: make production scalable, predictable, and easy to repeat. Synthetic nitrogen fertilizer and chemical weed control helped do that. And once that structure locks in, it creates friction for anything that does not fit. One long-term dataset shows U.S. nitrogen fertilizer inputs rising from under 1 teragram of nitrogen per year before 1950 to more than 11 teragrams per year by the early 1980s. USDA reporting also shows total use of nitrogen, phosphate, and potash rising from 7.5 million nutrient tons in 1960 to a record 23.7 million tons in 1981. Soybeans fit this new default. Uniform annual planting, standard equipment, a huge processing system that turns beans into oil and meal, and a buyer network that kept expanding. USDA analysis notes U.S. soybean production increased rapidly during the 1960s and 1970s, driven largely by export demand. Another USDA report documents exports rising from about 5.8 million tons in the 1964 and 65 marketing year to a record 25.3 million tons in 1981 and 82. That is what incentives look like. Once the buyer and processing are built, the system keeps pulling farmers back to the crop that is lowest risk and most repeatable. Now set pigeon pea next to that machine. Pigeon pea can fix nitrogen through rhizobia and can be used as food, feed, and green manure. But it does not arrive with the same market enforcement. In much of the mainland United States, it faces cold limits and, more importantly, no guaranteed buyer. A crop without a buyer becomes a crop without research pressure, and a crop without research pressure becomes invisible. Subscribe now, because the next step is where the paper trail gets interesting. The paper trail does not show a ban. It shows a quiet downgrade. Pigeon pea is documented inside U.S. institutions, but in places that rarely set the national farm conversation. The USDA Plant Guide describes pigeon pea as introduced in the United States. It says it has been successfully grown in the southern United States, Hawaii, and Puerto Rico. It explains the deep taproot, nodules with rhizobia, and drought resistance. That is not fringe material. That is a federal reference written to help people use plants correctly. But a plant guide is not the same thing as a market. It does not build buyers. It does not force universities to make it a priority crop. Older regional records show the same pattern. A Hawaii Agricultural Experiment Station bulletin from the early 1930s describes pigeon pea present in Hawaii by at least the 1860s. It notes organized distribution and breeding work. It even states the crop occupied roughly 10,000 acres in the territory of Hawaii during the previous 10 years, with part used for pasturing cattle and part used in rotations. Puerto Rico's agricultural history materials also discuss pigeon pea's long cultivation and movement across regions. Again, a real staple with real history. So why does it feel like it does not exist to most Americans? A crop becomes common when it is the default answer in extension, the default contract at the elevator, the default line in a seed catalog, and the default option a farmer can plant without explaining it to anyone. If pigeon pea lives mostly in the margins of U.S. agriculture, it will be treated like a curiosity, even when the science is sound. That is how knowledge gets erased, without anyone needing to censor a single sentence. That quiet downgrade has a price tag, and it shows up in places most people never connect to a soybean field. USDA's own farm expenditure summary shows crop farms spent about $31.9 billion on fertilizer, lime, and soil conditioners in 2022. That was one of the largest line items on the crop side of the ledger. When a whole system is built to repeat that purchase every season, the incentives push toward inputs first and biology second. Even when biology could carry part of the load, then the bill keeps traveling downstream. NOAA explains the Gulf of Mexico dead zone through a simple chain. Excess nitrogen and phosphorus, much of it from fertilizer applied across the Mississippi watershed, runs off during rain and snowmelt. It feeds algal blooms. The decay helps drive low oxygen waters. So the cost is not just money. It is dependence. Plus environmental cleanup that no single farmer can solve alone. If that sounds like a system problem and not a farmer problem, comment the number 9. And here is the part that lands like a cold weight in your stomach. Pigeon pea is not extinct. It is not mythical, and the USDA has published guidance on how it can be used as a pulse crop and a soil-building plant. But the system we built makes the easiest path the one that repeats the purchase. When U.S. crop farms spend about $31.9 billion a year on fertilizer, lime, and soil conditioners, that is not just a cost. It is a default habit baked into the structure. And when excess nitrogen and phosphorus run off into waterways, Noah explains how that nutrient load can help drive the Gulf of Mexico dead zone through algal blooms and low oxygen. So here is the simple accountability question. If a crop can help feed people and help rebuild soil biology, why do we act like it does not exist? Comment the number 9 if you think that question is fair. If you do not agree, hit like. And if you want the next episode to map the exact incentives that keep good crops invisible, subscribe now. And subscribe again if you want the receipts.